we simplify a Boolean expressions in SOP forms with the help of Quine McClusky method and QM, or you can shortcut, you can say QM method. In this way, these are the, here in this you can see don't care has been added here, and doing the stage number 1, stage 2, and we did not, we at the same way we have to proceed. That means 4 in 11 here, 4 in 11 is also been included, and then we made it then exactly in the same way. We group it in the first stage. We group them according to the number of ones available. This is the number of 1 is 1. This in this group number of 1 is 1 and 2, that is 3, that is 4, and we grouped it in according to the number of ones available here. After that, we start mapping the first group. Each element of the first group will be mapped with the each element of the second group. Then after the mapping, we see that here in this, if you mapped with 4 and 9, there are 2 places, 2 elimination happens. Therefore, you can say W is eliminated and Z is also get eliminated. Therefore, that is not to be considered. That is an important thing. If the 2 elimination happens, not to be considered. Now 4 and 12, therefore here only 1 elimination happens. Therefore, in the place at W, that elimination happens. 4 and 12 is elimination. In that way, if we continue the mapping of each element of the group 2 and the next, immediately next, then this it creates these groups it creates. And again I repeat that if there are 2 elimination happens, you should not put 2 dash, and that should be not to be considered. And in this way, after the third group to be mapping with the fourth group, we got this one. As for example, 7 is mapped with 15. The first element is eliminated, 7 and 15. And when we grouped with the 11 with 15, the second B is got eliminated. Therefore, we put it here. In this way, each element will be mapped with each element of the next group. After that is the count of ticking. Therefore, here the 4 is used. We have 4 is ticked. 4 is used. Therefore, 4 is been ticked here. And then you can see the 9 has been used. 9 is also ticked here. Then you can see 12 is available. 12 is ticked here. Therefore, 7 is yes. Then 11 ticked. Then 13 yes. Then 14 yes. 14 is also available. Then 15. All are ticked. Exactly in the similar way, you can proceed for the second stage, and we prepare a third stage. The second stage, you can see the first element, this has to be mapped, and all is mapping this element with the next. We have to see that the dash should here in the first place, and if you want to map, it should be in the first place only. But in any of the elements here, that there is no element where the dash takes place in the first place. Therefore, no mapping of the first group with the second group. Therefore, no, 4 and 12 is not at all mapped. Any of them. Then you come to the second and third. When you come to the second and third, you have to map it here. Therefore, 9 and 11. If you mapped with this, you can see that it is in the third. Dash is in the third place, and you can see only one is possible. Dash is in the third place. After mapping that, you can see 9 and 11 is mapped with the 13 and 15, and therefore this get the B bar and B get eliminated, and we write in the third stage. Therefore, 1 double dash and 1. Therefore, we included 9, 11 and 13 and 15. In this way, each element will be mapped with the next group's each element, and we got the third stage. After the third stage, there is only one group, therefore no other groups are possible. Therefore, no fourth group is possible. But now we have another important thing. Whichever during the whichever in the third group, whichever the elements are used, that should be ticked. You can see 412 is not present anywhere. Therefore, it should not be ticked. 911 is already there. Then 913 is there. 1213 is there. 1214 is there. Then 715 is not there. Don't take it. Then you can 1115 yes, 1315 yes, 1415 yes. Therefore, these are the, in this you can see stage number 2 there are 2 unticked elements, and here obviously there is no ticking. Therefore, here now we come to this, the prime implicants. Here prime implicants are, this is x, y bar, z bar, and another is there, that is x, y, z, and here w, z, here w, x. These are the 4 prime implicants. After that, we come to this table here. These are, we write in the prime implicants. Here we write the prime implicants, whatever we got in the this making the, yes, we got the prime implicant. We write in the table the prime implicants. We write in the article, and then we write the mean terms. Here it is very important that what are the don't care we have that should not be retained. That should not be included. Don't care should not be included. That is the main difference. Don't care should not get in. After that, we just gone tick mark. Therefore, this is 9. This is the 9. 11 is and 11 is your don't care. We have not included. Therefore, 9. Then this is a 13, and this is a 15, and this is 12, 13, then 14, 15. Then this is 4 is a, it comes under don't care, it is not available. Then 12, and then 7 and 15. Now we can see that if it is, this is x, y bar, z, but if it is not included, then also all min terms are been included by these three prime implicants only. Therefore, the solution is here wz plus wx and plus x, y, z. This is the solution of this, because this is not included, because excluding this also, all the min terms are been included in this. Therefore, this is the solution. If we verify with the K-map, we just plot it here. We can plot the K-map here, and we can see that this is the grouping is, this is the one group. This is the for this it is, you can, this is the wx, this is yz. Therefore, for this group, that is the, obviously this is the wx, and another group is possible. This is the group. This is the group. You can see this is the x is get eliminated. Therefore, this is the w, and in this way, this is a y get eliminated. Therefore, this is the wz, and remaining, this is the last. You can say this is w get eliminated. Then x, y, z. If you compare these two, this is the same result we are getting.